Welcome to this explainer. Today, we're unpacking the architecture of the future, edge computing for IoT and machine learning. If you've ever wondered how billions of smart devices process data without completely crashing the internet, well, you're in exactly the right place. We're going to build a modern edge network right from the ground up.
Our mission today is actually pretty simple. We need to make you aware of different edge computing protocols, like MQTT and Kafka, and see how they're used for predictive analysis to support edge applications. Basically, we're looking at how to transform dense, heavy device data into lean, predictive power.
So here's our roadmap for today. Number 1, the edge computing landscape. 2, edge networks, specifically M2M and WSN. 3, pipelines, covering MQTT and Kafka. And finally, number 4, analytics and machine learning. Let's dive right in.
Section 1, the edge computing landscape. Let's set the stage. The core problem we're solving today is that big data is just heavy. And latency? Latency is the absolute enemy of modern tech. Imagine millions of sensors trying to send raw data back to a central cloud all at the exact same time. It's a catastrophic traffic jam just waiting to happen. The solution is supporting edge application deployment through data management and predictive analysis. We build a highly structured edge environment to manage and analyze that data right where it's born, saving both time and enormous amounts of bandwidth.
Think of an edge pipeline as this massive high-speed filtration system. Step 1, we catch the raw data through M2M and WSN networks. Step 2, we pipe it effectively using MQTT and Kafka protocols. And step 3, we filter it down into predictive analytics. It's a literal journey from a raw mess of numbers to crisp, usable insight.
Moving on to Section 2, Edge Networks, M2M and WSN. This is where the data begins.
So how do these devices actually connect and organize themselves? Because before we can run any fancy machine learning models, we have to apply the right physical and logical layouts to actually capture the data efficiently. If this foundational layer is wobbly or disorganized, the analytics above it, they just fail.
The first topology we'll look at is M2M, or machine-to-machine. This is an edge analytics network topology used to connect devices directly to one another without any kind of middleman. Picture a fast-paced factory floor where a robotic arm talks directly to a conveyor belt to adjust its speed in real time. It's incredibly fast, totally decentralized, and forms the bedrock of our data generation. It basically acts as the localized reflexes of our network, reacting instantly without needing to ask a distant server for permission.
The second key topology is WSN, which stands for Wireless Sensor Network. This is an edge analytics topology utilizing distributed sensors to monitor physical or environmental conditions over potentially massive areas. Think of smart agriculture, right? You've got hundreds of tiny sensors pinging soil moisture and temperature levels across thousands of acres. They form a broad, distributed nervous system for our edge network.
All right, Section 3, pipelines, MQTT, and Kafka. Let's talk about moving the data. Having vast amounts of data is great, but if it's just stuck on a sensor out in the middle of a field, it's completely useless. We need to identify MQTT and Kafka applications for the end-to-end edge pipeline. To bridge that gap between our isolated devices and our powerful analytics engines without dropping packets or overwhelming the local network, we rely heavily on these powerful transport protocols.
Now, comparing MQTT alongside Kafka as the core computing protocols for the edge pipeline is really interesting because they serve very different yet equally crucial roles. MQTT is famously lightweight, literally perfect for a low-power WSN sensor with a spotty internet connection. It's like a feather. It barely makes a dent in your bandwidth. Kafka, on the other hand, is a heavy-duty data streamer. It can ingest massive, rushing volumes of data all at once. If MQTT is the network's capillary system, gently pulling in tiny drops of data, Kafka is the central aorta, pumping vast torrents of information exactly where it needs to go. Together, they form the absolute critical transport pillars of our whole pipeline.
And that brings us to Section 4, analytics and machine learning, the final destination.
This right here is the ultimate realization of edge computing. It's what we've been building toward. The realization of big data analytics, the application of predictive analysis, and utilizing open-source tools for edge ML. This is where we finally turn millions of raw metrics from that factory floor or that farm into active, decision-making intelligence.
By applying those edge analytics topologies for predictive analysis used in the investigation of edge computing, we unlock something huge.
We can run predictive analysis directly at the source. We're no longer just reacting to a broken machine and suffering hours of downtime. Instead, we are deeply investigating that continuous stream of data to predict a break before it ever even happens, meaning we only schedule maintenance when it's absolutely necessary.
But to pull this off, we must identify processes used for big data analytics in the realization of edge computing. The real magic here is sheer speed. By processing locally at the edge, we aren't waiting on a centralized cloud server halfway across the country to crunch the numbers and bounce an answer back. We save massive amounts of bandwidth and, perhaps more importantly, precious milliseconds. In industrial settings or, say, autonomous vehicles, those milliseconds can literally be the difference between a smooth operation and a total system failure.
And the best part? You really don't need a billion-dollar proprietary setup to do this. We can see the demonstration of Edge ML techniques using open-source tools. This completely democratizes the edge, giving developers everywhere the actual power to build smarter, hyper-efficient local networks without massive upfront capital.
This technology is moving incredibly fast. We've laid out the blueprint today, from M2M sensors through MQTT pipelines straight to localized edge analytics. So I want to leave you with this final thought to chew on. What are the current trends in edge machine learning technologies available in the market today? How is this blueprint evolving right now? Thanks for joining me on this explainer, and keep exploring the edge.